Dimensional analysis is the most important math technique you need for success in high school chemistry. And this lesson will give you an introduction. The dimensions we're talking about here aren't like, if you're a science fiction fan, talking about traveling to another dimension, okay? The dimensions we're talking about here are measurement dimensions. So you've got a dimension of mass. That's a measurement dimension. And we measure most of the time in a chemistry lab, we measure mass in grams. There you go. And we measure distance is another measurement dimension, okay? And we measure distance in what? In meters or centimeters, millimeters sometimes, or even smaller dimensions of measurement for distance. We're going to measure volume. What do you measure that in? Milliliters or liters, okay? Sometimes cubic centimeters. In medicine, they often refer to cubic centimeters as cc's. It's the same thing. A milliliter, a cubic centimeter, cc, they're all the same size measurement. They all mean exactly the same thing. But that's what we're talking about when we're talking about dimensional analysis here. So we're defining or looking at dimensions of measurement and analyzing those in terms of doing math. So this is the kind of math we do most of the time in chemistry. Okay? So let's start with this idea. I'm going to relate dimensional analysis to what you've already been doing all these years in algebra and math classes. Okay? Let's say we're starting with an amount of 3x. Okay? That's our starting amount, 3x. And let's say that 2x is equal to 5y. Okay? This is kind of a funny statement, the way I put it, but it's going to relate to what we're going to be doing in here and tying in what you've already learned about algebra, okay? So we've got a starting amount of 3x, and we have that the fact or the known equality that 2x is equal to 5y, okay? And this little part right here is an equality statement. Okay, we know those two things are equal, so we call it an equality statement. Okay? And what we're trying to find out is how much y is there. If we have 3x to start with, and if 2x equals 5y, then how much y is there? Could you solve that problem? Well, you should be able to solve that problem with the algebra you already know. Okay? Let's look at it this way. If I have 2, and I know that 2 equals 2, right? Would you argue that's wrong? We're good with that? 2 equals 2, right? If I put the number 2 over the number 2 in a fraction, 2 over 2, what does that equal to? 1. If I have a dozen of something, and I put that dozen over 12, what does that fraction equal to? 1. So what can we say about two things that are equal that are put over each other in a fraction? The fraction always equals 1. Okay? Now, a unit means kind of like 1. So when we have a fraction where the two parts, the top and the bottom, are equal to each other, then we can build from that concept what's called a conversion unit. You've heard the word conversion unit before, probably, but you probably didn't know that's what it means. It means we've got two things that are equal to each other in a fraction, one on top of the other. And it's a unit because it basically equals 1. What do you get when you multiply something by 1? The same thing, right? So there's another concept. We can take that conversion unit where we've got one thing that's equal to another thing on top of each other. It equals 1. You multiply something else by that 1, you get the same amount at the end, right? So what that allows you to do is what you're doing is converting from one unit, or in this case, from x's to y's, without changing the value. We know how much y there is from x by using this equality right here. Here's how it works. We're going to take that 3x, which is our starting amount, right? we're going to convert that to y. We're going to put that 3x over 1 just as a placekeeper to make it all nice and neat. All right? And we're going to multiply it by a fraction. We want that fraction to be built from this equality statement, because building it from the equality statement means that fraction equals 1. Multiplying by 1 gives us the same amount to start with. It just changes how we're measuring it, so to speak. Okay? Let's see. Let's put the 2x on the bottom. The reason I want to put the 2x on the bottom is because I want the x's on the top here to be canceled by the x's on the bottom here. Okay? So I want to put 5y on the top and 2x on the bottom. All right? Now, if you multiply those together, you get 3 times 5 is 15xy over 2x, right? Can I simplify that? How would I simplify that? Huh? X's cancel out. Okay, whatever the value of x, it's the same with top and bottom. They would divide out anyway in the long run. Okay, and we do the math, we get that 3x is equal to 7.5y. That is the basic idea behind what's called dimensional analysis. The only difference is, instead of using x's and y's, we're going to use those measurement units we talked about earlier, grams and milliliters. Okay? You with me? All right. Now, let's simplify this whole process, okay? Because I can take a whole step out of this. Let's go back and put 3x over 1 times 5y over 2x. And notice that the x's cancel out over here, right? What if I just skip that step altogether and cancel them out while I'm right here? As long as the x's are on the top and bottom, they can cancel out. Does that make sense? I just cleared up one whole step right there. And does anybody still have a calculator yet? Okay, if you got a calculator, get out your calculator. Let's show you how to put that in there. Okay? I know your calculators aren't actually going to be graded until you get here on Monday, but it would be good for you to start practicing. Okay? Because the way we're going to do math in here is going to be the same pattern all semester. Okay? Here's what you do. You multiply everything across the top. So 3 times 15, and hit your equal sign. All right? Then you're going to hit your divide key. Okay, so 3 times 5 equals, then hit the divide key, put the 2 in, hit equals again. You got all that? Did you get that 7.5? And that's going to make your math easy in this class, okay? If you just kind of keep up with the steps. All right? Everything across the top, hit equals. Then you divide by what's on the bottom. Now, right now, we got a one-step thing on the bottom. In the future, and I'll remind you of this when we get to it, we'll have multiple steps on the bottom. And you have to hit equals between every division, okay? Some calculators will do it without it, but if everybody does it the same way, it'll work out, okay? So everything across the top, hit equals. Divide by what's on the bottom, or one step on the bottom, hit equals. And any future steps on the bottom, keep doing those. You can multiply everything across the top as one thing, but what you divide by on the bottom has to be done in separate equal steps, or equals in between, okay? And so we get 7.5y, and we took out one whole step there. Got it? All right. That's the idea. Now, instead of using x's and y's, let's use grams and something called moles. Okay? I'm going to let you know that 12.01 grams of carbon, and that's the chemical symbol for carbon, is equal to 1 mole of carbon. Okay? Now, when we have two things that are equal, what do we call that? Equality statement. There you go. So this is our equality statement. I've given it to you. Sometimes in our problems, you have to figure out what the equality statement is, and when you have to figure it out, I expect you to write it down. Okay? But for right now, I've written it out for you. So let's say we have 45 grams of carbon. Let's see if we can figure out how many moles that is. Okay? So, what's the starting amount here? 45 grams of carbon. So what do we do with the starting amounts to solve these kind of problems? Put it over 1. Now then, I need to convert, and what am I going to put on the bottom here? Up here, I had x's on the top, and I wanted x's on the bottom. What do I need to put on the bottom here? Not 12, yeah, well, 12.01 grams. What I'm really looking for here, you're right about that, is I want to make sure the units, and in this case, this is called a species, okay? The chemical is the species, all right? So units and species. I'm going to put the units and species on the bottom that match what I have in my starting amount. So I'll go up here to my equality statement and find which side of this equality statement matches the starting units and species and put that on the bottom. Okay? And then I put the other side of the equality statement on the top. Can I simplify without having to combine it? What can I simplify? No, yeah, grams are going to cancel out. It turns out the species can also cancel. I didn't put moles of carbon, that belongs there. Okay? And I can convert from grams to moles. So do the math, and let's find an answer. If you got your calculator, good chance for you to practice. Now look, if I multiply by 1, what's it going to give me? So really, we don't even have to multiply this times 1, do we? We can go straight to taking this and dividing by that. You got that? All right, so what do you get? Those of you who got a calculator. Well, it will become that eventually, but we're not there yet. Okay, I haven't talked about rounding yet. Okay, right now I want you to remember you're going to write down every digit your calculator shows. Some calculators are going to show more digits than others. That's okay, but you're going to write down every digit your calculator shows. Got it? Now, we've canceled grams in carbon, but we haven't canceled moles in carbon, so we're going to keep those. All right, so for right now, this is an unrounded answer that I expect you to have. You got that? That seem hard? Now, before I give you your homework problem here, let me just make really clear about something. I know you guys have been taught cross multiply and cross divide, right? For this class, and this class only, and don't tell your math teacher I said this, but I want you to forget you ever learned that. Okay? That will trip you up. I've seen it happen more than you can know. And the only problem is, it works great if you know when you can use it and when you can't. And that's where the problem comes in. I want you to use this dimensional analysis process for this class. You're not going to get tripped up with this. Okay? If you go back and try to figure out when to use cross, multiply, and divide, some of you, maybe most of you, are going to get tripped up. Okay? So just don't do it. Just forget you know cross, multiply, and divide. Okay? Good enough? All right. So for this class, I don't want to see cross, multiply, and divide at all. Got me? All right? All right. So here's your homework problem.